unfortunately. And if you've done a little bit of maybe ACT or SAT, they're not on the SAT at all? Okay, they're on the ACT. So sequences are what? You did?
Yeah, different.
I thought they were still on the SAT, but not very much. There might be like one or two questions.
I have a basic question at the end. It's tough.
Yeah,
well,
I didn't know we had different tests.
Well, everyone.
Yeah, everybody gets different tests. Basically, a sequence is just a list of numbers. And
Ours usually do. Ours usually do. This case, by the way, I'm recording the lesson for Uri.
She also is.
Oh, you're right. Thank you.
so this chapter, we're going to be doing sequences. The next chapter are all on series. So what's the difference between sequences versus series? Well, sequences are just a set of numbers.
How do you say the plural of series?
Series.
And when we have a series, that's going to be the sum of the terms. Okay? So this is just a pattern of numbers. This is taking that pattern, if there is one, and adding them together. Okay? All right. Okay, so we will look at finite sequences and infinite sequences, right? That just means domain is finite or infinite. We'll start off with geometric sequence, which hopefully looks familiar. Okay.
-32.
What does it mean to be geometric? Has a common ratio, which is R. Right? So we start off with a first term and then we multiply it. So the explicit rule or the nth term is given there. We don't really worry too much about recursive rules for this class. Okay? Remember the recursive is when it depends on the previous term. Right? The a sub n minus 1. Okay. All right, so here we have geometric series. Let's find each of the following. What's the common ratio? This should be a short lesson, by the way, because hopefully. What is it? R is what? -2. You can just take any two terms. So we could take the second term over the first term, the third term over the second term. It doesn't matter, right? And we get -2. Okay, what's the explicit rule for the nth term?
8.
Well, what's the first term? 1. Do you really need the 1 in front? No. But if it was something other than 1, you just want to make sure you include it, right? Or you could just have -2 to the n minus 1. And how do we find the 20th term? Just plug it in. So a sub 20 and you probably need a calculator for that.
4,652. Negative.
Oh, my calculator's.
It doesn't matter. There won't be anything trig-wise that makes any difference.
See me trying to figure out.
Shane was close.
Problem that I didn't
It was a job, Shane. River was probably easy.
Okay.
Thanks, Adam.
All right. Look a little bit familiar. It's been a couple years.
Oh, wait a minute. Yeah.
Yeah.
This was the worst lesson. Second worst lesson of the week.
Not even that
That was
bad.
the worst lesson.
So there's a few lessons in BC that we'll have to revisit topics from pre-calc that we haven't seen in a while.
Everyone's tripping over pre-calc chapter 5.
Okay. Oh, sorry, this one?
Simplifying like cosine.
Okay, second and fifth terms in a geometric sequence are 6 and -48 respectively. Find the first term, common ratio, and an explicit term. Or sorry, explicit rule.
Wait, isn't it times 10?
Oh, is it?
Well, I got -520 with like a bajillion zeros.
Maybe I just didn't write it all out.
Yeah, that doesn't make sense.
No, it makes sense.
-20.
Oh, oopsie.
I feel like 2 out of 19.
Okay. Guys, don't be annoying. Okay, second term. The second term is 6 and the fifth term is -48. Okay. So we want to come up with the first term, common ratio, explicit rule. So we're going to revise the formula from the previous page, which was this, and I'll write a sub 1 r to the n minus 1, and we will rewrite it with our fifth and our second term, right? So we'll write that as a sub 5 equals a sub 2 r to the 5 minus 2. So replacing our nth term with 5 and our first term with 2, right? So we have negative 48 equals 6 times r cubed.
48 divided by 6.
Oof, 48 divided by 6.
Come on,
It's
buddy.
rough.
You got it.
Come on, we got this. It's negative 8. And then the cube root of negative 8, negative 2. So we found the common ratio.
We did it.
Okay, now we have to find the first term.
Negative 3.
Nice job, boy. That was fast.
Thank you.
And how did we get negative 3?
How do you get the first term?
Well, we have the second term, which is 6.
This is divide. Negative 2.
Yeah, I mean, yeah, you can just divide it.
So it's negative 3.
Yeah, I mean, and what if this was like the 7th term and this was the, whatever, the 12th term or something like that? You could still plug it back into the formula and come up with the first term, right? You have enough.
3.
So you'll still end up with negative 3, right?
Always
So
negative.
a sub 1 is negative 3. And then a sub 1 will be
Negative 3 times 2.
negative 3 times negative 2 to the n minus 1.
Wait, what did we time? Oh, yeah.
Okay. Limits. Okay, we know what limits are, right?
Yes.
So we should know by this point. So we want to look at the limit of the nth term of a sequence. So if we have a limit, meaning it has to be a real number.
We do low hoppy tall rule.
Yeah.
Little hoppy doll.
If it applies, we can. So if it approaches a real number, we say it converges. If they don't have a limit, then we say it diverges. Okay. This will be a big topic throughout this chapter and the next chapter, when a sequence or series converges or when it diverges, right? So when it diverges, usually what happens to our limit is when it diverges, it either goes to positive infinity or negative infinity, or it could oscillate and not approach a real number.
Could it be 0?
What if it oscillates approaching 0?
Okay, so if it's oscillating approaching a real number, then it converges.
Nice.
Because again, it's right, as long as it's approaching a real number, it could be 0, it could be 5, it doesn't matter, it's still going to converge, but it can still oscillate along that value. Okay. And yes, so all of the rules that we've done for limits are going to apply here. So if we want to do L'Hopital's rule, we can do L'Hopital's rule. If we want to do, if we
do
want,
that definition of a limit.
what? The definition of a limit?
Like definition of a. Oh, never mind.
You're trying to find the limit of.
Oh, you're thinking of definition of
That's what I
derivative.
was thinking.
No. There's no definition of derivative here. So all we need to do,
Probably laughing harder.
here we go.
I really want to say it, Chase.
It would be appropriate for class.
Please.
chat.
I really want to say
It would
it.
be appropriate for class chat.
I really want to say it.
So therefore, a sub n converges to 2.
Agreed.
And keep in mind, the values of n are always positive integers. They're whole numbers, okay? So you're not talking any negative values, which is why we only look at as values approaching positive infinity. But again, if I were to write out what would the sequence look like? Like if n is 1, what would we have here?
2 and over 4.
right?
Oh, if we do the,
What's that?
how do you find the A over 1 minus R?
So that's only if it's geometric.
Not this.
Is this a geometric
No.
sequence? We could tell right away by the first 3 terms it's not geometric because it would have to have the same what? Common ratio, or it would have to be multiplied to the same thing. But right away we can see it doesn't have that.
So how do you find that?
Does it? Well, no, and listen, geometric series, we'll get into series and sequences, but if it's not geometric, then it's just a sequence. Not all sequences are geometric, right? Geometric is one specific type. What's this? Okay, so the -1 to the n, what does that do to our sequence? It just oscillates between a positive and a negative value. So the -1 to the n doesn't, whoopsie. So it's really just looking at this. What does the limit go to? 0. So there's for a sub n converges to 0.
I'm sorry. He's like, this guy's cracking jokes.
All right, all
But
right.
isn't -1 to the infinity determinist form?
Okay, you have to think of this is not, what do you mean?
But we're finding the limit as n approaches infinity, right?
Yeah.
So if we, what about the first -1 to the n?
But you have to think of this as a sequence. So imagine what you have here is like you have, for example, when n is 1,
You get like,
you'll have a value like down here, right? Then it'll go up here, then it'll go here. And what's happening, right? It's going to oscillate, but it's going to get closer and closer. Does it matter -1 to the nth? That just means this is what's going to tell us what it converges to.
Anyways, cancel it out because it's times easier.
You're right.
Good. How about this one?
take it diverges.
Infinity/dn, so it diverges.
Yeah. Because whenever this is greater than 1, it's going to approach infinity,
So there's no divergence.
diverges.
That's a good one.
Like I said, this is a pretty... Okay, now we'll go back and revisit that -1 to the nth term. If we just look at the absolute value of the function or the nth term, and it goes to 0, then we know the nth term has to go to 0. Okay, so this part B is an example of that. So as long as this goes to 0, then the whole thing is going to go to
It's the
0.
same question.
Yeah.
So we're doing
No, it's the same thing.
It goes to 0, converges to 0.
Converges 0.
So I'm just showing to use the limit. So if it says use the absolute value theorem, oops,
It doesn't matter.
it doesn't matter. That's all. Yeah.
Is this just saying like the absolute value is 0, 0? So if it was like the absolute value of that was like 1, we wouldn't know if it was 1 or -1.
Well, we know these are only positive integers, but this will make it a positive or a negative.
Okay.
So taking the absolute value basically removes this part. Okay, how about B?
One half.
So it converges
So 1/2.
to 1/2.
Oh, that was something like.
Yep. That's what I said.
Wait, what's next?
What do we have next? A? Is it A?
Bonus.
C? I don't know.
It's
C.
C. I've heard it is C.
Specta?
Wait, is that?
I have Specta.
There is no A today.
That's physics.
What graphing sequence are you gonna do?
No, that class is really easy.
What graphing?
Taking a test.
Practice graphing sequences.
Yes.
They're close to these. Close to
What does that mean?
But when it's time to like pay attention.
So if we want to graph, for example, one of those, which I would like to just look at, if you go to your graph and your graph entry, oopsie. We have,
Whoa.
Whoa.
What is that?
Whoa. 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 What is that?
Can you explain this?
Did you do
okay,
Did you do custom or sequence?
just do sequence. Okay.
That's pretty funny.
It's just the notation that the calculator uses
That's pretty cool.
to
though.
represent a sequence.
I've never seen something like that.
Okay,
Whoa.
so instead of x, what variable are we going to use?
N.
A or N?
N.
No.
It's
N.
either A or
It's u of n. It's using a u instead of an a. Why does the calculator?
Because it's cool.
It's
You know,
Texas
it's
Instruments.
online
It's what they came up with.
A substitution.
It's Texas.
Okay.
We pronounce their A's like U.
Whoa.
So do we put in?
I'll do part A. I'll
So
just
is
do the
Is that the first value or what?
I don't have Calc.
Mainly. How do you say calculator? Go.
hold on.
How does he teleport though? Like it's
I didn't see him leave the
Got invalid sequence.
Oopsie.
Because you gotta balance either.
Where did Uri go?
I didn't see him leave.
Like, yeah, I really did not hear or see him walk out of the class.
I didn't
Go back there.
Miss Casey, did you
What?
sound him as absent for this?
Yes.
Yeah, actually,
He does
it's
not
looking
have-
at it a little bit.
If you are gone from class for more than 10 minutes, it counts as an absence.
I'm gone. Oh,
What
What
about
way
what
he
about
has-
11?
Because I'm frequently gone from class for more than that.
I don't think
11.
So do I have to put in the initial time?
Oh, no, you don't have to put the initial. You just type it in.
Wait, can you go back?
It's like
I'm
Can you
actually
push
gonna
tab?
say-
Can you push tab and go back?
so. Wait, it doesn't include any of the
See that?
things.
So how do you
between-
change the
This gives you-
initial terms? What does that mean?
No, you don't worry about that. You
What
just
is
put the
that?
function in.
What is
Okay,
that?
but I'm curious about the end of step 1. What if you said that's 2
Yeah.
or to 0.5?
What if you do?
Okay, well, where do you usually start n equals? One.
2.
Then 2, then 3.
Just me and I can say.
Wait, so what does initial terms do?
The real MVP.
Oh, let's see.
That's if we want to define it differently. But if we're just putting the function in, it's automatically going to make the first term.
Fuck this.
Oh, is the
Okay, so-
subtotals rule just the lesson like just subtotals rule?
See, and then it will fall.
Chapter not explained.
This case.
So you can kind of see what's happening. And you'll
Can
see
you have a
here at the
question?
bottom,
Can
if
you
you
type
just
in-
trace it,
Can you type in a value? Kind of like type in 100.
it'll give
I'm
you,
sure
it'll
it'll
jump
say
to the
0.
next value.
This case.
So you can kind of see.
Can you
Okay.
do, on this part, can you do like add factorial